Cylinders and cones. Now, if you watched my screencasts on prisms, then working with cylinders and cones are going to be very similar to that, okay? Now, the nice thing about cylinders is you only need to know two things. You just need to know the radius of the base and the height of the cylinder itself. Okay, now we're going to get three things here. We're going to get the lateral area, and that's going to be the circumference of the base. Okay, so that's 2 pi r, and then we multiply that by the height, and there's your lateral area. The total area, we just add the base areas to it. Well, the bases are circles, and so we have 2 pi r squareds because we have two bases. And then finally, the volume, just like with a prism, it's the area of the base times the height. Well, what's the area of a circle? It's pi r squared times the height. So here's an example. We have a cylinder with radius 5 and height 10. We're going to find its lateral area, its total area, and its volume. So here's how I draw a cylinder. I draw an ellipse. Well, I missed, didn't I? Draw an ellipse, and this radius here is 5. Then I'm going to go straight down, and I'm going to draw a solid half of that ellipse and then a dotted half like that. And the height is 10. Okay, so the lateral area is the circumference 2 pi r times the height, h. Okay, that's going to be 2 pi times 5 times 10, which is 100 pi. Okay, total area. Well, the total area is going to be the lateral area plus the area of the two bases. So it's going to be 100 pi plus 2 pi times 25, because the radius is 5. Square it, we get 25. Whoop, that's a plus. Okay, and that equals 150 pi. And finally, the volume is the area of the base. Okay, that's going to be pi r squared times the height, 10. And that's going to be 25 times 10 is 250, which gives us 250 pi. Now, a cone is like a pyramid, except instead of its base being a square or a rectangle or any other polygon, its base is just a circle. Okay, now you need to know three things for a cone. You need to know what's called the slant height, which is L. That's this length right here. You need to know the height of the cone itself, which is this height from the top of the cone straight down to the center of the base, and then you need to know the radius of the base. Okay, now the lateral area of a cone is pi times r times the slant height, L. The volume of a cone is 1/3 pi r squared h. In other words, it's exactly 1/3 the volume of a cylinder. So here's an example of working with a cone. We have a radius of a cone is 5 and the height is 12. Now to draw a cone, I'm going to start out like I'm drawing an isosceles triangle, except I'm going to draw an ellipse along the bottom. And this radius is 5 and the height is 12. Find the lateral area, total area, and volume. Remember, we need to get that slant height. I hope you recognize that this is actually, right here, a right triangle, and we have a Pythagorean triple. 5, 12, 13. There's our slant height. So the lateral area is pi RL, which is pi times 5 times 13. And that's going to be, let's see, 65 pi. Okay, total area. Total area will be the lateral area plus the area of the base, pi times 5 squared. The base is just a circle. So that's 65 pi plus 25 pi is 90 pi. And find the volume. The volume is 1/3 pi r squared h, which is 1/3 pi times 25 times 12. Okay, so 1/3 times 12 gives me 4. 4 times 25 is 100, so we have 100 pi for the volume. Okay, here's our last example. If the radius of a cone equals its height, what is the volume in terms of the radius? Okay, so this is going to look sort of, well, I messed up, didn't I? Forgot I was doing a cone. There we go. Okay, so here's the radius, and the height is also equal to the radius, so I have an R and an R right there. So what's the volume? The volume is 1/3 pi r squared times the height, which is r, and I get 1/3 pi r cubed. So that is the volume in terms of r.